So earlier I forgot to introduce myself. My name is Scott Hogue. I'm with the Rocky Mountain IPv6 Task Force and the Infoblox IPv6 Center of Excellence. I welcome you again to this event on behalf of the North American IPv6 Task Forces. I'm going to present this next speaker, John Curran, President and CEO of the American Registry for Internet Numbers, ARIN. They are responsible and responsibly manage the resources like IP addresses that we all use, and have been an organization that's been aligned with the task forces in terms of evangelizing the benefits to businesses and organizations of IPv6 and trying to further adoption. We're going to be presenting an award to John Curran today, the IPv6, what do we call it? The IPv6 Evangelist Award, the IPv6 Lifetime Achievement Award, not to reflect your age, but your longevity you've been in the industry. John and the American Registry for Internet Numbers has sponsored all of the North American IPv6 summits that we've had over the years and have really given us a lot of support. And John has always made time out of his busy schedule to be at our events, to share his knowledge and thoughts on IPv6, and we truly appreciate his support of our events over the past decade or more. Little background on John. He has been involved in networking, building networks, operating networks, managing networks since the internet's very early inception. He's been involved in the IETF back when it was called IP Next Generation, IPNG, and that became IPv6. And so with that, we have an award for John that we'd like to present him, but it's not physically here. There was a mess up. The award had to be made with some gold leaf. Their suppliers used IPv4, and there was an overlap in IPv4 address. Carrier grade NAT issue. It was a total mess. We have some manufacturers of the award out looking for super glue to affix the rubies and emeralds to it. So thank you, John.
Appreciate it.
Thank you.
Thank you, Scott.
So without further ado, John Curran.
Well, thank you. I'm very happy to be here, and apparently thank you for granting me an award for Lifetime Achievement. I'm glad I don't need a walker to get up here with my elder age, but I have tried to do a bit for the internet and for building a better internet for over the years. I've been doing this, as Scott said, for about 30 years now. So this slide says the future of the internet, IPv6 and the long tail. And it also has President and CEO ARIN. A lot of the slides don't say ARIN. I'm up here in my personal capacity. You folks know ARIN. We do what you want us to do. We run the registries the way you want. You set our rules. You set our procedures. You elect our board of directors. These are my thoughts. These aren't ARIN's thoughts. They're not member thoughts. They're not the board's thoughts. Most people would disavow these thoughts, so I made sure that on the slides it only has my name on it. There's a few ARIN slides in the middle when we talk about address issuance and things like that, but these very much are my personal views, and I wanted to be clear about that. I'm going to talk about why we did what we did. Why did we do IPNG? Because it's not obvious, actually, when you think about it. And then a little bit about how we're doing. And then someone asked me to talk about how to get an IPv6 address block from ARIN. And I was like, I'm speaking to the NA task force, right? And they're like, yeah. I'm like, these people don't need a remedial course in how to get an address block. But I put the slides in, so you'll see. And then when is IPv4 going away? Because that's everyone's favorite topic. And this room has the power to make it happen, and I'm not sure they're going to, but we'll talk about that. And then what does the future hold in general? So, to build a better internet. So the problem we were facing in the early 90s is that it was very clear that the internet was too successful. If you looked at the Address Lifetime Expectancy Working Group in the IETF, Frank Katzenholz and Frank Selinsky, they had done some graphs that showed we had about 30 years before we ran out of IP addresses. The IETF actually spun up a routing and addressing group which had two recommendations. The first recommendation was stop giving out IPv4 address blocks. Pretty close to that. Actually, they said stop giving them out the way you were giving them out. You're giving them out on bit boundaries, /8, /16, and /24, and that's stupid. We just need to change a couple of routing protocols, and you can give things out on variable bit boundaries, aka CIDR. So that was the first recommendation out of the Routing and Addressing Working Group. The second one is, even with CIDR, we're doomed. IPv4 is not going to take us to the end. We need to revamp the internet protocol, form a task force to do it, a directorate. So they formed an IP Next Generation Directorate, IPNG. 13 members, I was one of the members. Many people, you know, luminaries from the IP field were sat on this, Steve Deering and Jim Bound and folks like that. And we worked on the new internet protocol. We called out for white papers, received 30 some odd white papers on various aspects, requirements, things that should be in and not in. And we had a whole bunch of proposals, actual technical specifications for how we were going to do this new internet protocol. Just make the addresses bigger, change other fields, what do we do? But at the end, they boiled down, there was a little fratricide as proposals killed off one another and merged. And at the end, we had about 3. We had tuba, sip, and catnip were the 3 that were in the beauty contest at the end. Now, a little context here. This is all going on between 1992 and 1994. The world's a very different place then, okay? In 1992 and 1994, multi-protocol corporate networks were the rage. Everyone was buying their multi-protocol router. Companies up and down this road, a few others made them, and connecting them up with their leased circuits and running them. There were a few people who were moving on to new transport technologies because the telcos had gotten a hold of the future, and they were saying, don't use circuits, use ATM or frame relay to connect up your routers. And everyone was thinking IP was one protocol, but it was going to be one of many. We had people talking about 20-year DECnet plans and 20-year IPX plans. And the assumption was that even the internet was going to be multi-protocol. Even the internet was going to be running multi-protocol. There was an IPNG requirements document that actually said the internet has to be multi-protocol, not just IP, because that's what people expect of it. This is the world we're in. Now, the problem, of course, is that the telecommunications industry overspecifies everything it sells. What it sells you is so constrained, you can only use it for what they want. There's not a lot of flexibility. You can't create new services, you can buy the services from them. The internet, we had a much more open approach. A minimal packet delivery service, and you can build anything you want on it. All the intelligence at the end of the network, not in the middle. And so this was the paradigm in the early 90s. When we boiled down the white papers and made the requirements, here's what we agreed to do. Overcome the 32-bit address space limitation. Obviously, that had to happen. If we didn't overcome the scale issue, we had failed. But we wanted to maintain all the good stuff. And we actually said, let's maintain the good stuff. Decentralized nature, topological flexibility, performance, robust service. Robust service means non-robust service. It basically means we'll try to transfer your traffic, but it doesn't get there, you have to handle it. Presume the network's not robust, so make your applications robust. Media independence, unreliable datagram service. As long as we provide an unreliable datagram service, well, if we did that, then people could build anything they wanted. Dynamic configuration, we had gotten to the state where people realized things like DHCP were cool, and we needed some way like that to get addresses. Multicast and some control protocol, ICMP-like protocol. We want to maintain those features. Some of the things that's not in there, fragmentation reassembly, yeah, that didn't make it. Some other little details that didn't make the list, but the ones that we did, we put down. And this is in RFC 1726. We added some new things. So secure network layer operation and inherent mobility support were in the requirements. You can see them. The first one means effectively authentication header and secure ESP header. What is IPsec for v4? And the second one, inherent mobility support, was the idea that you'd be able to get a packet, and if you moved to a different location on the network and your network prefix changed, that you'd still be able to process, your connections would work, or your UDP traffic would still work. That's a very interesting thing to be in the requirements, given what we ended up with, by the way. So anyway, and then most important, the requirements said a straightforward transition plan from current IPv4. So those are the requirements. What didn't we put in the requirements? What we didn't put in, now the goal was not just to expand the address field, obviously. If you knew you were going to be mucking with the core protocol of the internet, then you were going to try to get as much distance out of this one change as you could. So it wasn't just expand the addresses, it was fix the protocol, make the protocol better to build a better internet. But we still didn't put everything we wanted in, and we did put some things, like mobility support and secure network level operation. What didn't we put in? Variable length addressing. In the 90s, there were still people trying to get over the fact that hosts and routers were different things. And if you thought that hosts and routers were the same things, then the length of a host CPU word was very important. And the idea of variable addresses was impossible. Mentally, it was a bridge too far. Now, of course, nowadays, you think about all the virtualization and things going on and all the number of, wow, wouldn't it be great if every computer could actually spin off longer addresses for every virtual machine, and every virtual machine could spin off more addresses for processing? Oh, that would be so cool. Yeah, we don't have that. So we left that out. Decoupling of network transport identifiers, this is actually very, very amusing. I actually don't know how you don't do this and provide mobility support, but somehow we did. We left one out without the other. So the idea would be your transport headers only get checksummed on your transport headers, and you don't care about the IP address where it comes in. You don't care about the interface because it's a valid transport header. And the idea would be that you'd separate the two, and you could default them and use endpoint identifiers for your network and for your transport identifiers as well. But if you move to another part of the network and the next TCP segment came, it wouldn't be the end of the world because you were only worried about the lower bits. Yeah, we didn't like that. People said we'd break security if we did that, and we'll come to security later. Quality of service, we didn't put that in. It was interesting. It wasn't in the requirements, what I mean. Policy-based routing also wasn't in the requirements. We said it would be something to have. But these were being talked about in researches, and these were being talked about in the IETF, so we talked about them, we said they're not required. Feature differentiation. I actually wrote an RFC at this, RFC 19, 16, 14, let's see. Wow, the numbers get long. 1669, 1664. Go look, it's IPNG market differentiation. And basically, I said, look, we have to have some new features in v6 that aren't in v4, period. Other than address translation for transition plan, we have to have something else. We have to have something other than just longer addresses. Because if all we give people is longer addresses, this protocol doesn't do anything for anyone until we run out of addresses. And that would be stupid. No one would go through the work of building a whole new network protocol and not feature differentiate it between v4 and v6. Yeah, that was left out of the requirements as well because people said, well, anything that we know how to do in v6, we're of course going to put in v4, IPsec, security headers in v6, et cetera. Dynamic configuration of addresses, DHCP, or SLAC. So we didn't get an agreement that we're going to do feature differentiation. We did know we were building a protocol for a better internet. RFC 1726 IPNG technical criteria boiled down what the final criteria were. It is difficult to change a protocol central to workings of the internet as IP. More problematic is changing it frequently. This simply cannot be done. We believe it's impossible to expect the community to make significant non-backward changes in the IP layer more often than once every 10 to 15 years. In order to be conservative, we strongly urge protocol developers to consider what the internet will look like 20 years and design to that vision. Look out and see what we need. Don't just fix the address problem. So that's what we did. And we had to look at the criteria that came in, final criteria we agreed on. We had to look at the proposals and choose one. So what do we end up with? We ended up with IPNG, which came from the SIP one, by the way, SIPP, Simple Internet Protocol Plus, or Simple Internet Protocol. Someone has to go find Bob Hinden and ask where each of the P's came from, because I have no idea anymore. But anyway, what do we get right? We got larger address space. We got functionality. The basic IPv4 functionality is preserved. We got the security. What did we not get right? So I was on this directorate. I was in the meetings. I was in the 2-day decisional summit. And there's always times when you look back at your life and say, did I do the right thing? As we get further down the road with V6, I spend further looking back on the final decisions we made. Not that could we have done better, but why didn't we know that we were doing worse? Because that's actually more important. Of course, anyone can look back and say, we could have done better. The question is, what didn't we see? What were we enamored with? What was clouding our vision that caused us to make the decision we did? Because there are bright people. You got very, very bright people involved in this process. But what didn't we get right? Scale. Well, we didn't get the variable length network identifier. Every cloud provider on the planet right now is hitting us with a stick because we didn't get this. Quality of service. So it wasn't a requirement, but it was so exciting to talk about that we put in a field for it, a flow label field. Policy-based routing, same thing. We had no idea how we were going to use this, but there were people who were really excited technically about the future of this. So we stuck in the ability to do source routing in V6. This, of course, everyone who's familiar with the history of V6 knows later on we went back and assassinated some of this stuff, but that's okay. Feature differentiation over IPv4. Yeah, we didn't get that, even though we knew the consequence was people would ignore V6 until the last minute. We still didn't agree because the IETF said, oh, we don't really control that. Well, you control V6, you control V4, you kind of do control it, but okay. Native mobility support, wow. We'll talk about mobility in a little while, and I'll come back to this, but the insanity of what was done is amazing. If you actually look at the IP mobility spec, the RFC in the 6,000 level that just came out, or came out came out 5 years ago. Wow, I'm old. So if you look at the IP mobility spec, it says, in the spec, it says, we have to do all this with these forwarding headers and servers and keeping track of home register, all because there's no inherent mobility support in IPv6. And then you go back and you go, wait a second, we said inherent mobility support was a requirement. Here we are in 2011, designing an entire mobility system because we somehow didn't put it in the actual spec. Okay, and of course, simple transition plan, don't get me started. We need one transition plan, not 40. We ended up with 40, of which 25 of them didn't work. So that's where we are. Now, despite that, yes?
Can you elaborate on your regrets about QoS? Like what went wrong or what was wrong?
We had no idea how we were going to use QoS.
Can you restate the question?
Oh, sorry. With respect to QoS, the question was, people believed that the internet was going to provide services with different levels of quality, and that to do that, flows would have to be tagged, and therefore, in the IP packet header for IPNG and IPv6 now, there was a flow tagging field put in, despite the fact that we knew not what the values would be, not what protocol would set them, not how they would handle router decisions, not how they would handle queuing decisions, but let's put a field in there anywhere. By the way, that's one of the reasons why V6's header is so large, because even though we have a lot of things, that field was actually a substantial component of the new header. All right, so despite all this, folks, boy, it's interesting giving this to an IPv6 task force. Yeah, get excited, even though it didn't look very exciting. Despite this, how are we doing? We're actually not too bad. Let's talk about this. Talk about how many networks have IPv6 blocks, and then how much traffic is using V6. Okay, percentage of members with IPv6. This is organizations in each of the RIRs that has an IPv6 block. LACNIC, 87%. I'm very impressed with that. I have no idea why. RIPE, 75%. I'm very impressed with that because a lot of those are routed, and that's very impressive. ARIN and APNIC, about half. That's actually, given that we've just started running out of numbers in like ARIN, just September 2015, that's actually a pretty impressive uptake. Same with APNIC. AFRINIC a little behind. AFRINIC's dealing with connectivity first and V6 connectivity second. Requests for V6, consistent, and that's for the last 3 years, pretty steady. we get about 80, 90 organizations coming in every month looking for IPv6 requests. And if you look at the membership and you look at the ones that just have IPv4 and the ones that have IPv4 and IPv6, that's a beautiful graph because that shows we're actually crossing 50, 60%. A lot of organizations now realize they need v4 and v6 finally, and we're seeing a good uptick, and that means a lot less of v4 only. However, take the data, cut it the other way, and do a histogram based on who, and it looks a little different. So when you look at IPv6 adoption by size, the largest organizations, well, it doesn't really fire. Do not look at laser with remaining eye. Okay, maybe it does, okay. So largest organizations, I got it, yep, it's there, okay, those. Extra large, large, 2x large, these are all categories of size we've expanded now in the top categories. The largest organizations are 80, 90% deployed, or not deployed, have v6 blocks and are in somewhere in their deployment. When you look at the small ones, you're in the exact opposite situation. These are organizations that have a /20, /22, /24 IPv4 size and are an ISP. And a lot of them have nothing. There's many of them that have no IPv6. And so that's a problem among our ISPs. And I spoke to a number of small ISP associations, like the Whisper Association, and it's we're back to why deploy IPv6? If you're not growing, you don't need v6. You get someone who's growing 5 customers a year, okay? They can figure out what they're doing with IPv4 addresses. They really can. There is absolutely no reason, because why? We didn't put any feature differentiation in. Without feature differentiation, there's no reason for them to sell the customers a different service. It's a lot of work with no upside for them. And so it makes a lot of sense. Whereas the largest ISPs all have growth rates that they have to worry about, therefore v6 is required. If you know someone who's in the red on that graph, an ISP that doesn't have a v6 block, here's the 12 pages of my presentation that talk about how to get a v6 block. No. Here's the 1 page. I gave up, guys. This is pointless, okay? Call us, okay? Just call us. We'll get you an IPv6 block. It's not hard. If you know someone who needs an IPv6 block, have them call us. I can count the number of declined requests on one hand, and those are generally people like your next door neighbor on a cable modem who wants a v6 block, even though he doesn't understand he's not an ISP. Okay. And that's not really turning them down as much as educating them. Call us or send us email. Hostmaster is the address at ARIN.net. If you have an ARIN Online account, have them go in and say, I want v6. We have staff that you pay for to help them get v6. So since you're paying for that, why don't we make sure that those staff have something to do? So just send someone to us. It's pretty simple. Okay, let's talk about traffic now, not allocations. IPv6 traffic growth, that's Google's IPv6 stats and shows some 30% of their US traffic. On the global scale, 16, 17% on a very nice curve. We're actually doing reasonably well in North America for IPv6 deployment and traffic, given again that the only feature is addressing IP address runout. If you look at particular providers, we're doing really well. Mobile, this is from Akamai. Eric, I can't remember his last name. Put this up, and this shows for various providers their particular growth rate over the last 3 years in mobile for IPv6 traffic. And as you can see, mobile is driving it all. That's where our success story is. Now, let's talk about v4. The fact that mobile's driving v6 doesn't matter, okay? Doesn't matter at all. I have bad news for you, okay? The fact that v6 catches on does not mean v4 will die. It's a very different circumstance. The reason that IPX and DECnet and CLMP died is because the internet was more useful. And so people stopped doing those. Actually not true. Raise your hand if you're still running a DECnet, CLP, or IPX network. Oh, come on, guys. Yeah, the feds have, banking, manufacturing. Wow. It's DECnet in manufacturing still. It's like scary. But there's the number of networks you can count on, you know, it's probably 100 networks on the planet that are still running this. So in general, these networks have gone away because the internet provided more functionality. But there's a weird thing going on here. You can't do a killer app for v6 because people don't buy the internet for one app. They buy the internet because it's an aggregate service. It gets them to everywhere they want to go, where everywhere is everywhere. They don't know where they want to go. They don't know who they want to talk to. You saying, I've got one app that only runs on v6, okay? Unless that happens to be their life and they're completely consumed by it, it's like offering a cable plan that has just one cable station on it, okay? Yeah, there's some people who are going to buy that, but most people want to get all the shows. Well, same thing. We have a long tail problem here. The audience wants all the services on the internet, so even if we get 80, 90% of the traffic on v6, doesn't matter. There will always be a long tail of v4 only services. You will always be maintaining dual state. Your kids will be maintaining dual state. You'll be upgrading software in dual state. Congratulations. Yeah, aren't we happy? Isn't this great? Okay, I'm giving the uplifting talk. This is the uplifting talk, okay? We are going to be doing this forever because internet services connect to anything on the internet. And IPv6 will never get there to what we're doing. Yes, we'll have great deployment, 80, 90% of the traffic. But that doesn't mean you won't have to deal with v4. Now, I've stared at this for a long time. I stared at this thought, this graph, this idea 14 years ago and said, that's too ugly to think about, got drunk and came back and put it away for 5 years, came back about 5 years later, did the same thing. 5 years ago, I looked at this and I said, we have to go back to what we were trying to do. This is not about address space. This is not about address space. IPv6 is not about address space. It's about building a better internet. So the IPv6 forum isn't about address space. And it's not about a protocol. It's about building a better internet. Now we're talking. Best way to predict the future is to create it. We've done an amazing thing. We've changed what internet service is. Internet service used to be, I can connect to v4. We've now put a stick in the ground and said, no, it means I can connect to a v4 or a v6 resource. That's what we've defined internet service as. Now some providers are like, well, maybe kind of. We don't have providers, we don't have everyone sold on the fact that internet service should be able to connect you to either a v4 or a v6 resource, but we're getting there. We've made great progress, and probably in the next 5 years, it will become fairly well understood that an IPv4 only service may not get you to all of the internet. But the fact that an IPv4 only service doesn't get you to all of the internet doesn't mean an IPv6 service gets you there either, okay? So we actually have to overcome this by doing something more. We have to do better. And this is very hard because we got to success with v6, think about that mobile traffic. We got to that success because of individual providers taking actions, individual technical decisions. It doesn't work anymore. This is not a technical problem. We don't have a lot of technical problems. Now, we do have technical problems, guys. Just look at the v6 Ops mailing list, or now whatever they've renamed it, and you just pound your head against the wall with all the problems we have. I'm not saying we don't have problems, okay? But what we're offering is the same service on v6 as v4. Now, we're telling the v6 people, oh, you can get the v6 and v4 sites, because we have some magic gateway somewhere, or we'll give you both stacks. But inherently, what we're offering you is that basic packet delivery service, that quote, robust packet delivery service, and do what you will. We haven't raised it all. We haven't raised the bar. Now, if you want to have IPv6 be the only network protocol 20 years from now, then we have to offer something different on the IPv6 internet than on the IPv4. And that does not mean a turtle who flies through the air. I do not talk about bespoke porn that you can't get anywhere else, okay? I'm literally saying we have to offer a different service. Now, again, look very carefully at the slide at the bottom. Let's see, there's my dot. There it is. There it is. John Curran, right? Doesn't say ARIN on any of these slides, so I disavow this. This is my views of what could be done. You may have different views. What do we want the internet to look like? At the end of the day, what the internet is going to be like is not going to be based on the technology. It's not whether you use V4 or V6, guys. Some people in the room will tell me V6 runs a little faster, and I'll be like, yeah, if it doesn't go through a NAT to get to the V4 person, it runs faster because it's V6 end-to-end, but the same could be said for V4 end-to-end, and there's a little bit about routing table diameter and number of hops, and when we finally get everything moved on to V6, we may have the same number of hops, so I'm honestly not sure anyone can argue we've substantially moved the ball. So if it's not technical, how do we solve this problem? How do we do something different and build a better internet? Because that was our goal, right? I mean, that's why we did this. How do we do this? If we've got no technical differentiation, remember we agreed not to, even though we really thought it would be a good idea, we agreed not to technically differentiate IPv6. Yay. So we have no technical edge. We're not doing anything different. We're not offering any different service, okay? The internet succeeded because it has a great open model. Anyone can build an application. You don't have to ask anyone's permission. You don't have to go register. You know, when you go and create a new service, raise your hand if you know Minitel. Minitel, France, Minitel. You know, when you create a new service in Minitel, you actually have to go through the amount of paperwork, back when Minitel was around, you had to actually go through the amount of paperwork to almost create a government agency to create a new service because you had to be approved to create a new service. Insane. There was a while when if you wanted to add a host to the internet, you had to get approval to get it connected status for its network, and then you had to get added to host.txt. Yes, I am that old, okay? And if we had grown the internet where you had to get approval every time you connected a host, we wouldn't have an internet today. That's kind of the telco model, though. Telco model is, I'm going to give you a service, and what you get is what you get. You do with it what I tell you to do, and nothing else. When we went from that telco model to the great open model, we got all this great growth. The internet is a success because anyone can innovate. Permissionless innovation. However, there's a price to that, okay? Let's talk about the price. To you folks, the internet's a wonderful place. To your non-technical person out there, the internet is terrifying and getting more so, okay? One of the things we had when we had the phone network and central control is we actually knew everyone was on it. And if you did a bad job, you got kicked off. We don't have that anymore. It's wide open right now. I tried to figure out how to express what my grandmother feels about the internet. I can't because she's dead. So I tried to figure out what my mother feels about the internet. And I asked her, and she gave me some words, but it didn't really put it into. She likes the internet, she likes the connectivity, but she's terrified. She feels like she's described it as she's locked in her own house. She's terrified to venture anywhere for fear she'll get mugged in her own driveway. The equivalent online. She only goes to the few sites she has bookmarked. She's frightened, okay? Because we really created a system that's so wide open, we don't know who's using it or what they're using it for. So I was trying to look, there must have been a social paper or some analysis that talks about dread of this. Now again, difference between secure and secure. The internet's quite secure. Yeah, we have inherent security. You have authentication headers and ESP, and we have all sorts of ways to secure your web traffic. That's not what we're talking about here. It's not technical security. They're literally fearful of going to a website where it has a beautiful certificate, but it still robs them of their money, or it somehow breaks into something, or it downloads a virus. It's not security of the computer, it's security of person. And that's what we lost. We lost it, it's gone. So I was looking for a paper online, and I didn't find it. I did not find it. But I found a poet, girl in the US who's a poet, and somewhat into goth. And she wrote a couple of paragraphs, and I'm going to read you this because it was what summed up one view of the internet about what we've created, our proud creation. Did anyone notice how quickly the internet has turned into a Lovecraftian horror scenario? We've got this dimension right next to ours that extends across the entire planet, and it's just brimming with nightmares. We have spam bots, viruses, ransomware, endless legion of malevolent entities that are blindly probing us for weaknesses, seeking only to corrupt, to thieve, to destroy. Add into that the corrupted ones themselves, humans who have abandoned morality and given up the faces to hunt for other people, jeering them, lashing out, seeing how easy it is to kill something you can't touch or see or smell. They'll corrupt anything that they could think could be a vessel for their message, and they'll jabber madly at anyone who questions them. Their chittering haunts every corner of the internet. They are not unlike the spam bots in some way. Add on top of this the arcane magisters, who are forever working at the cracks between our world and the world we made. Some of them do it for fun, some do it for wealth, others do it for the power of nations unwise enough to trust them. There are mages who work to defend against this particular evil, but they are mad prophets, and their advice is almost never heeded, even by those who keep them for protection. All the people know several spells to use the internet. Facebook asks you to incant magic words to log in, as does your mail, as does your Twitter, and so on. The spells are words or gestures with one hand. Some use the color of your eyes or the shape of your finger. Our chief of security just joked about requiring users to give a drop of blood before they could log in. Many do not understand the humor of mages. The cracks between the two are breaking. IP cameras fill our world with eyes, and the magisters learn how to open them, almost all of them, every time. We carry magic slabs of glass that if you hold up to your ear, can sing with your loved one's voice. But if you look at it with your eyes, show corrupted humans screaming at you with the profanity of 1,000 voices. The other day, I saw someone hack a moving vehicle. At one point, they made it stop. The other day, they made it so it couldn't stop. Some of our best and brightest are going to create an army of four-winged bats hovering through every city, and we are going to connect them directly to the dimension where the nightmares live. Then let's see what life is like. I'm not saying it's all bad, but I'm saying Cthulhu lies, deathless dreaming in this web we built for him, and he is waking up. That's our internet for some people, folks. Now, the reason I say this is because it's an opportunity. The completely registered and controlled telco model was over here. The completely wide open and effectively anonymous without recourse internet is over here. It's not a binary value tree. There's a lot of decisions in between, okay? I know what the next innovation in internet will be. It's not technical. We're at the point where the technology is indistinguishable from magic to the average user. Doesn't matter what you do, they don't see anything different when they log in. It really doesn't matter. You can automatically get HTTP secure certificates, and to them, it's still a web page, folks. The technology and the changes really don't matter. Governments are beginning to look at this. I don't know if you realize how much of the average economy is now built on the internet. If you're a government and your job is to protect your people, that's your mission. You have public safety, you have the economy and the health of your people. And you realize it's all built on this internet run by magicians who you have no idea what they do, and you do not trust them, okay? And occasionally parts of it go down. You hear government ministers from other governments say, yeah, we were taken out. I remember I was yelling at a guy in a meeting, and 2 days later, we were taken out for 12 hours. I don't think it was him, but it might have been someone he hired. The fear of not knowing, are you going to be up tomorrow? Is your economy going to be running? Are all of your horns going to go off at 2 a.m. and wake everyone up, okay, is literally palpable for a government person. When governments get afraid, they make laws. And they enforce laws. Governments have one unique power no one else has. They have the use of force, the legal use of force. So when governments are afraid, it's something for us to pay attention to. Now, you have a new internet. You have it. This room, okay, has built a new internet on IPv6, okay? It's a different internet. You'd like to see everyone on it, but you're running it the same way as the IPv4 internet. You're not distinguishing operationally how you're running the IPv6 internet, okay? And you could. There's no reason to say you have to run it the same way. Do you want to have DDoS attacks on IPv6? No. Do you have them now? A few. There's a few out there. I saw them. Actually, some of you have heard from me when I saw the DDoS on v6, and I'm like, how did you end up with a DDoS on v6? There really aren't enough bots to support that. We can shut that down now. You can shut that down now. You might want to spend 5 times much attention trying to figure out how to prevent botnets from growing on v6 than you do on anything else. Because if you build a network that doesn't have botnets, or if you build a network that uses whitelists instead of blacklists, because blacklists with our address space is kind of amusing. If you build one that uses whitelists instead, and you do a positive assertion backbone for email, you could end up with something that's actually different than the current internet. Something that's actually better than the current internet. That's pretty cool. A better internet will cause something that wouldn't have happened otherwise. People will actually say, I want to be on the better internet. I don't know why it's better. Someone told me it has longer bits, but I still don't know why it's run better just because it has longer bits. Well, it isn't, so it's run better if it's run better. But the fact is, if you build a better internet, you can actually get people to move to it. If you get people to move to it, you might someday be able to say, no, I'm not supporting 2 protocols for the rest of my life. Questions? Yes?
I think this is more of an ARIN question. Hold on. I think this is, hello? Okay.
Yep.
I think this is more of an ARIN question. It has to do with the gray market and Adrex and some of those guys. What's the policy of the RIRs? And I think they were different, but I think they might have come together as far as when you do get that, don't you now still have to display the need for address space before it will get transferred to you? I'm just kind of curious on, I think you know what I'm asking.
I'm going to give you you asked a 30-second question, and I'm going to give you a 3-minute, 4-minute answer. First question, what's an address block? What is it?
I need a /22. Is that what you're asking?
Yeah, what is it? No, what is an IP address block? If I assign you an IP address block, what did I do? What is the address block? Because we're talking about rights in address blocks, right? So we have to know what the address block is in order to discuss the rights in it. What's an address block? Is an address block the right to route an address on the internet? No. We don't control routing tables. You control routing tables. ARIN does not, none of the RIRs control the routing tables, okay? You can route any address block you want. You can route it in your lab, you can route it on the public internet, if you can get a peer to agree to it. We don't control routing. The address block is a reservation in a table that says this range of numbers is only uniquely associated with you, one party. Now, this means a whole bunch of interesting things. Once you get the definition of address block down, everything else flows down. So let's talk about it. First, people have address blocks that were assigned before ARIN, before other regional registries, before LACNIC, okay? Everyone got their assignment out of this registry. But you're using the registry for cooperation. You don't need RIRs. You don't need them. If you don't have RIRs, I won't come speak, by the way, but you don't need them, okay? You could do your internet yourself. The first guy says, I'm going to use the number 1. The next guy says, I'm going to use 2. The next guy says, I'm going to use 7. He's a jerk. The next guy goes, wait a second, I have to ask everyone else what's being used. 1, 2, 7, I'll use 4 because I'm a normal person. You could all get in a room. Now, the problem is when you get enough people together, number 9,000 to join goes, wait, which ones are in use? Oh, you have to ask everyone. No, that doesn't work. So for the voluntary coordination that you do to make numbers work, you have a registry. So someone can say the next one's 9,002, here you go. The fact is you want a voluntary coordination so that when you use numbers, you don't stomp on anyone else, but it's voluntary. We have no control. All we do is provide one uniqueness service. Now, all the way back to your question. Okay. When you get address blocks, the people who got address blocks before ARIN's formation got them under rules of the time set by John Postel. These were formalized in an RFC called RFC 2050, and it actually talked about transfers. It said you could transfer your address block to him if he meets the same requirements necessary to get a new address block from the registry. So you can transfer from one person to another, but the recipient has to be able to get a block from fresh under the same criteria. That's actually the policy that applies to all the legacy blocks, the pre-ARIN blocks. I have legacy holders who are like, no, I don't have to meet that policy. Yes, you do. That's before ARIN. That's not my doing. And we didn't do anything. That's John Postel and the Intranet and the US government. That's the policy they had in place. So we tell legacy holders, look, we're going to be generous to you. As the ARIN community makes better and better, more relaxed policies, we'll apply those policies to you. Even though you're a jerk and you haven't signed an agreement with ARIN, even though you're getting free registry services and free reverse DNS, even though you claim that you don't like the registry and you're desperately trying to update the registry entry that you claim isn't your address block, okay, well, if it's not your address block, I don't need to update it. If you're selling something to someone and it doesn't involve ARIN, don't call me. It really is, your address block is the registry entry. And so the fact is we do, as the community changes the policies, we do make for easier transfers. And the last transfer policy, it's probably people in this room better than I am, but I think right now we're on, you have to be able to justify 50% of the utilization of the block within 2 years. Maybe 3 years. I can't remember. I have to look it up. And that's the policy the community set. Now, that means that there are address transfers going on. If someone transfers and comes to ARIN, we qualify the recipient. We say, are you going to use 50% of this address block within the period of time that the community policy says? If the answer is yes, we'll update the registry to point to them. We don't ask any questions, not our job, other than to get them to confirm that they're going to make use of 50% of the address space. Now, you can not go to a registry. You can just take your address block and loan it to someone. They can pay you money for it. They can even create a document that says they bought it. Now, if you buy an address block from someone, but they're not willing to update the registry, which is what I actually believe the address block is, they say, we're giving you the right to use, but we're not going to change it. Recognize they could do that deal with 7 people, okay? There was people in Florida who did this with swampland all the time. People do it with bridges now and then. They stand on the street walk and try to sell someone a bridge. You can sell it multiple times. That's fraud. So we do have transfers going on. The vast majority of transfers are reflected in the registry. I think you'd be personally insane to attempt to do a number transfer if the party said they weren't going to update the registry, because I honestly don't know what you're buying if they're not updating the registry. And I went a minute long. Answer your question?
I'll accept the other RIRs. Is there any coordination between RIPE?
Each RIR sets its own policy for transfers within the region and sets its own policy for transfers between RIRs. ARIN's policy says we will transfer to another RIR who has a reciprocal needs-based policy. So we go to RIPE and we say the recipients in your territory, as long as you have a policy that allows the transfer and you say that there's some needs assessment done, as long as you tell us they pass it, we transfer it. So the recipient qualifies in the region where he's operating under their policies. So there's both inter-RIR, in-region policy, and inter-RIR policy. Got it?
Yeah, and when you ask the customer, hey, you already have a bunch of space, but you want this other /16, so you're not verifying that they've swapped that or anything. You're just
We require they have an officer legally to attest to it.
okay.
If they attest to that, then we proceed, because that's the policy that the community's done. Now, you can affect that policy. Show up to an ARIN meeting. I know some people here showed up to ARIN meetings because I see a t-shirt on from our last meeting in New Orleans. But you can show up to the meeting and affect our policy by discussing the merits or the disadvantages of that change, because that was a pretty recent change. But actually, ARIN staff, we don't do anything with policy. We just turn the crank on the machine. You guys build the blueprint of what the machine does. Got it? Good. Okay, next question, back.
Yeah, sure. So I remember in ARIN 2008 in San Antonio, there was a lady from Stanford University, and she talked about them giving back, I think it was 38/8 or something to ARIN. I think it ended up in APNIC actually at the end of the day somehow, but that's a different story. And then I see the news here recently, MIT, they sold, I think,
Substantial
/9
portion.
or substantial portion of a similar block. So we have two different universities here in the US, and they're doing different things.
Oh, there's a very wide range of activities. Stanford gave back addresses, BBN gave back addresses, Interop, Trade Show gave back addresses.
Right.
All of these organizations that come down to give back addresses, I say, you don't have to do that. Oh, the U.S. Department of Defense gave back addresses. They gave up back the most, actually.
So I wanted to ask you, what was your thought, not as an ARIN representative,
Right.
but as John Curran, because it's not helping, V6 adoption if we continue using these old blocks. I would rather just see them die and people start, doing V6 instead.
Okay, so I would have been happy if you wanted that to be the motivation for V6 deployment. Then around 2000, let's see, RC 1997, say 2000, Linux, Microsoft. Around 2008 or 9, you should have come to ARIN and said, I want you to stop giving blocks and not allow transfers. So that will encourage V6. And if you got the community to develop that policy, you would have had more initiative. Mind you, it's pretty stupid to think that IPv4 having address space, the same addresses it's had for all these years, that somehow we should try to choke the very end to give IPv6 that little bit more lift. Okay? If IPv6 is going to make or break on what we do with the last 3% of IPv4, oh, we're in a sorry state if that's the case.
Sure, fair enough.
I got time for, a few more questions. Yes?
Yeah, so what's the cost of an IPv4 today?
So that's actually another very important question. What's the cost of an IPv4 address? So we process these requests. We do about 70 or 80 transfers a month. We ask people where to come from. We verify that they're actually the rights holder. We ask them who's it going to. If they're in our region, we verify that they meet the policy for our region. If they're in another, we ask, do you meet the policy for the other region? We call up, APRIPE or APNIC and say, do they meet your policy? We never ask who's paying what. It could be that there's no money going back and forth. It could be that someone had some old Dell servers and they traded it for a block of IP addresses. It could be that there's sheep involved. We don't ask, okay? We don't. Now, if you go to the ARIN website, get your minds out of the gutter. Okay, if you go to the ARIN website, okay, and you look, there's a list of facilitators. We call them transfer facilitators, about 8 or 9 of them. They all have phone numbers and email addresses. You can go look at the email addresses in their websites. Some of them actually post sanitized logs of their transactions that show the latest transfer prices. If you call them up, they'll talk to you for 30 minutes about how much you could expect to pay or how much you could expect to receive. Mind you, they'll ask you whether you're going to buy or sell before they have the conversation, because obviously those are different numbers. Between those, that's where they live. So I don't have hard data. If I look offhand, $10 to $12 per IP address for /24 within the ARIN region to another party within the ARIN region. So $2,500 to $3,000 for /24.
Yeah. Or 120 million for a /8.
So when you get bigger blocks, things get interesting. If you transfer them as a large block, it's a lower number. If you break it up into smaller sizes, in the more friendly, cloud company consuming /12 to /14 range, there's a lot of big companies who want that to number their next data center or their next set of servers. And so in that range, you'll still see $10 to $12. But if you actually try to do it as a /9, you probably wouldn't see $12, you'd see something less.
I wanted also to comment on the security of the better IPv6 internet. So we don't need to have anti-DOS for V6 because there's no DDoS on V6. And also,
can you make sure there's no DDoS on V6?
well, this is often
I've seen two. I don't, because if he says there's none and I saw two, then something's wrong here.
yeah, this is often the comment I get. The other one is, why do I need to do SPF and DKIM to send my email over IPv6? So there you ask me to do that.
So at the end of the day, it's what you folks want to do in running those networks. If you do not run a network that is materially safer, I don't mean most secure, because you guys kind of have arguments about RSA algorithms and key exchange and DKIM, and we could talk about that for days and days and days, none of which affects whether my mother thinks she's safer or not, okay? If you can make an internet where someone believes they're safer, then you can kill the long tail of IPv4. That's operations, it's not technical, it's entirely operations. It's entirely whether or not, when someone says, I have a DDoS attack, I am looking at it, I have the command and control address, okay? Now, I don't just want to turn it off. Why? Because if you turn it off, it moves, guys. We know this. It'll be up really quickly on another address. It'll be using the next 500 new top GTLD strings to control it. If you shut it down, it doesn't do a thing. And by the way, when we do shut down IP addresses with v6, there's always going to be another one. The only way you can actually make it safer is when you have that address, you can actually say, how quickly can we actually get to the party and their country? How quickly can we work with law enforcement to prevent this person from ever running another botnet? That's a different level of engagement. That would make a safer internet. It would make a better internet. It's not what you're currently doing. Okay, go ahead. Two more.
Can you hear me? Okay.
Yep.
Hey, John, how do you think we could better advocate v6 for the enterprise and the people that are not and even education in some places? Some of us come from R&E background where the internet was born, for more or less. And today I see, peers that, oh, it's not a problem. I was like, wait a minute, this is where we fostered this growth. This is where this happened, and yet you want to turn a blind eye to this?
So you said enterprise, okay? I'm going to answer that. A lot of enterprise is also, well, first, does anyone here work for a company which sells security solutions? Raise your hand. I apologize. Okay, so there are some people in this room who are in the racket business, okay? They're in the business of making you feel better because the internet's unsecure. They may not have a real reason to make the internet safer. When you look at the industry that enterprise ends up supporting for security, and I'm talking about firewall, DDoS mitigation, security enterprise manager, the layer proxy, the layers and layers of what now goes into the edge between the enterprise and the internet is huge, okay? Used to be companies actually, when they talk about security technology, they're like, oh, you're doing federated identity management and single sign-on. That's pretty cool. Single sign-on and federated identity management is this big. This perimeter stuff is now 80% of that security market. Okay. So if you want enterprise to get more excited about v6 and you can tell them that you can throw out 2/3 of that, they'll be very excited. But you'd have to actually be running a v6 network that didn't require all that cruft that the other guys in the room are selling. First statement. Second one, you talked about research and education. So earlier, oh, is Tony still here? Tony might have escaped. Okay, so we talked about deployment and mandates, and NIST does a great set of slides, a chart. You go to antd.nist.gov, something like that. Advanced Network and Technology Division, NIST. I apologize if Ron or someone else from NIST is in the room. But they actually do poll. They poll all the top government websites, and they see whether or not v6 is there and responding on mail, web, and DNS. They also do that. They also do DNS sec check, which is very cool. And they put that in a beautiful chart. And if you look at the US government chart, actually for an unfunded mandate, the US government IPv6 deployment's pretty impressive. 60–70% of the websites are v6 enabled. That's not bad. Now, go look at enterprise. They take the top 1,000 companies in the US and they do the same scan, and it's red. It's like 40%. But there's actually a worse scan they do, which is universities in the US. Those wonderful people who got involved in creating all this technology, you go to your average university, they have no idea what V6 is. There's 3 guys in the computer science department who know about it, and by the way, they think it's boring engineering, so they're not studying it. But the guys in the actual university IT department, they're like, oh no, we're not doing anything with V6, no one's asked for it. The universities are actually the one, when you look at it, the whole chart of 1,000 universities scanned for their website, it looks like it's bleeding red. It looks like someone stabbed it, and just red, not available, goes all the way down to the far end. So, yes, I'd love to see more enterprise involved, okay? But we'd also like to see some more universities involved.
That's what I'm saying, right? Some
Yep.
of us work very hard to make that happen, and then we confer with our colleagues and say, oh.
Yeah. Not in the list. Again, you're offering the same internet service you do over V4. Why would they move? All right, I got two more. Go ahead. One at the mic, and then I got Joe.
Okay, it's not a question, actually, it's a comment, but I really got something from your presentation. It was sort of an epiphany. I've talked to a number of regional carriers, smaller ISPs, who are building walled gardens for some of their users. One use case I remember in particular, I was arguing with the guy because he had a K-12 network, and he was providing them with a network that wouldn't give them any reachability to Russia, India, China, some other countries. And they were thrilled with it.
Yep.
Because the abuse traffic just dropped right off the cliff. And I was thinking of what I see as a resurgence of sort of semi-private walled gardens as a bad thing, because, I work in technology, been working on the internet for my whole career. But I hadn't really thought about it until you were talking about it as a service. And I mean, I know for the really big carriers, it's almost impossible because, of course, a fair amount of the abuse traffic is actually originating on their networks, and they can't figure out how to sort it out. But I hadn't ever really thought of it as a positive service that you can offer. But when I think about it, the reason that, say, this K-12 network wanted this walled garden was because they couldn't afford, it's like the barriers for them to participate in the internet were just too high with all the crap they were dealing with, and it was a tremendous enabler.
Right.
And I think I've just been thinking from a very privileged perspective about that this kind of protection is a bad thing. And anyway, you've really turned my thinking around. So
I'm glad that had an effect on you. Something to think about is that, and this is, this audience, you guys get it, okay? When you turn on V6, you're looking at an uphill battle because the whole internet's V4 and I'm turning on V6. I'm one little voice, okay? And yet you do it. And we've had amazing V6 deployment, despite the fact that we recognize there's a huge V4 installed base. You still know V6 is important. Okay. A clean, better internet is important. Even if 5 ISPs decide they're going to do a good job with it, and they do that for their V6 services, I would not be surprised if you find several organizations with VPNs say, we want to be on that, okay? You get a couple of countries doing it, and you will get other countries saying, I want to be part of that. You can build something and grow it. You can't say, because 98% of the internet originates at another network, this isn't worth doing. Okay, well, you've basically gone to the lowest common denominator then. You already realize with V6 you have to do more because you're deploying V6. You also need to do more operationally. If you do, you can actually create something that's very distinguished, okay? Right now, my mother sits and she described it this way. John, it's like I'm in my house and I know that I can hear people knocking on the windows and rattling them, okay? And it doesn't matter who I call, they're never gonna stop the guy who's out there. And I don't know if it's the same guy today as it was yesterday, but I can hear him every hour rattling on the windows, knocking on the doors, trying to open the garage. There are people terrified because they know they're constantly being attacked. They don't know what to do about it. They hope their machine is safe, and yet they know if they report it, nothing happens, okay? You wanna know why people are scared of the internet? That's a terrifying way to describe it. I tell my mother, no, I'm not one of those people, cyber hacker breaking into her computer, and she doesn't have to worry about me. But she's like, that's great, I don't have to worry about you, but I have to worry about the other 7 billion people on the planet. We need to figure out how to prevent that if you actually want a different service. Joe.
Okay. What would those features look like?
No mail except by authenticated hosts. Known
We know that.
authenticated hosts. Done. There you go. You build a spam-free internet. Let's say we had a spam-free internet right now. One where if you actually did spam, there would be a process where someone actually handled, you sourced this. Well, no, those were my customers. Okay, they were your customers. Oh, they were at this conference. Oh, maybe they were maybe they were at a conference and they agreed you could spam them. Okay, great. Someone would handle that, so the one time it's legitimate and the other 90 times it's not legitimate, and they just, harvested it off a mailing list or harvested it off something. If you actually built a spam-free internet, do you know how many people would switch to it tomorrow? Everyone. Hell, I'd be the first in line to switch, okay? Do you want to build one? That would be a better internet. Good example. DDoS. You don't have a lot of DDoS. I don't know what it takes to prevent DDoS from moving to IPv6, but my God, if I was the IPv6 task force, that would be my first priority is I'm going to build a better internet so that at some point people will want their application on v6 just to avoid the v4 line. Yes?
Yeah, also want to make one other comment. The DDoS providers typically don't have eyes on IPv6.
Right.
And it took a specific company to finally enable IPv6 services to find out we were being DDoSed, even though some of us have sensors around the internet and that have noticed DDoS for 8 years, but we didn't see detection of it until 4 years ago.
Right. And what you want to do now is, the question is, if that DDoS is coming from someplace you can't get at, that's fine. But if it's coming from a group of providers who collectively say, we don't want this, can you shut it down and know it won't reappear? If the answer is yes, you're building a better internet. All right. Sorry for raving at length. I will leave you to your conference, and I'm sure you're going to have a wonderful 2 days. I actually have to fly out later today, so I won't be around, but I'm very happy to be here. Thank you.